Hello, and welcome to the September 19th, 2018 edition of the Cluster API breakout meeting. For everyone who's made it in, just a reminder that we are using the new Zoom URL now, and hopefully people aren't waiting in the old one. I posted it to Slack. And it's also at the top of the meeting notes, and also a reminder that for all of our docs, if you open up the meeting notes for that meeting, it should have the correct Zoom URL at the top. And it's also in the calendar invite. So if you are synchronized getting the calendar updates, you should also see it there. The Zoom URLs are now specific to each meeting. So every different meeting you attend is going to have a different URL. And it's possible those URLs are going to change over time. In particular, when I created the URL for this meeting, it looked like I could schedule it something like 12 to 18 months out. But I think when I create the next meeting URL after that, it's likely to be different. So if you're wondering where to go, always take a look at the meeting notes or the calendar invite on the SIG calendar. And with that, we have a pretty modest agenda today. Hardik has offered to give a demo to get us started. While we're doing the demo, if people want to go ahead and queue other things that they'd like to talk about, we'll go ahead and do that.
Okay, so actually we have been working on Machine Controller Manager for quite some time. So we had also got a chance some time back to show the demo off, right? But at that time, the APIs were defined by us, and the cluster API project itself was quite in a nascent stage. So what we have done now is that we have basically migrated the APIs which we were using to the cluster API itself. So which basically means that the APIs that we are using are just imported directly from our upstream cluster API repository. Just that there are a couple of fields which are yet not introduced in our upstream APIs, which, for example, are machine states phase, then about provider ID and so on. So those things I took the liberty of adding for now, but more or less it's machine API compliant. So along with me, Prashant is also joining in the call, and we'll basically be showing you how MCM is working with the new machine API and how we have integrated the autoscaler with it.
Okay. Hi, everyone. So yes, as you can see on the screen, I suppose you can see my screen, right? So, okay. So you can see that we have created a branch called Cluster API, and we have, like Hardik mentioned, we have made the Machine Control Manager up to the APIs now understand the Cluster API. So what I have for the demo is like. So as we have discussed earlier as well, that we use machine classes to templatize our machine objects spec. So what I have is a machine class, which I've already created. So I'm just going to show you how the machine class looks like. So we have given it a name, we have given it a namespace, or all our machine objects are namespace. And so in the provider config, what we right now are doing is we're just embedding whatever fields we had earlier. So this is for an AWS machine. So we've just embedded it into the provider config itself. And so we have all the required details like the machine types, security groups, and things like that. What we have in addition to that is also a secret reference. So right now it's in parallel to the provider config. We are thinking of moving it inside. It's yet to be thought of. So what the secret ref would contain is basically, I have a dummy secret here, which would have the access keys to the cloud credentials, in this case AWS, and then the cloud init script. So we use the cloud init scripts to boot up our machines instead of the SSH way. So that's why we have it here. And then what I'll do is in my demo, what I'll do is I'll have an empty cluster, and I'll try to create a machine deployment and show you how it looks like from the high level, right? So this is the machine deployment that I'm going to try to create. It's a machine deployment, and so similar to a deployment, it has similar fields, replicas, strategies, and matching labels and things like that. From the provider config, and it's from the value from, and we are passing it from the machine class, right? And we are taking the name of the machine class. I had given the name of the machine class in the previous one as machine class version 1. That's what I'm using here. And you can use this also to do a pause or a rollback and things like that. So I've just given test comments, and maybe you can try it out if you get something. So keeping this in mind, I'll just jump into the demo. So what I have is, my screen is a little complicated. Maybe let me go one by one explaining what it would be. So this is the logs of the MCM. So what I'm going to do is I'm going to locally run my MCM. I have a cluster that's already up and running. So I'm just going to try to connect to that cluster and make this MCM watch over that cluster. So I'm just going to build MCM. And similarly, we have also modified the autoscaler to understand the MCM machine deployment objects. So what we have is, this is nothing but a normal cluster autoscaler run command. What we have new is the cloud provider now says MCM. So it understands that the cloud. So we have implemented a new interface called MCM, which makes it understand and talk to the machine deployment objects that our machine controller would act on, right? And so here in the nodes, we are giving it a range of 1 to 5 nodes. You can scale from 1 to 5. And this is the name of the namespace and the machine deployment itself. And all other fields are pretty much the same standard autoscaler fields. I'll just start the autoscaler in parallel. Maybe the autoscaler is the second part of my demo. I'll just start it in case. Right?
I have a question about the nodes parameter you're passing in. You put the namespace and then a dot and then the machine deployment. Is dot an illegal character in namespaces or machine deployments, such that is something you can reliably split the string on?
So I didn't get the question. So we could split it a different way. That's what. So at this moment, it's just for the reason that in the autoscaler itself, there is no otherwise way we could inject the namespace from any other door. So we just wanted to club these two guys together.
Yeah, no, I was just wondering if, like, right now you're going to do like a string.split on that dot character to separate the namespace from the pod. Is it illegal to have a dot as part of the namespace or as part of the pod name so that it's a reliable character to split on?
That I'm not sure, but I'm not sure if namespace has illegal character of dot. It's a good point. Yeah. But at least in machine deployment name, we don't allow the special characters to be start from. So it has to be any character first.
Yeah, we'll have to check on that and maybe we'll get back. So yes, sure, I'll continue the demo. Yeah, so yeah, and I have a watch on the node objects over here in the same cluster as well as the pod objects. What I also additionally have is a watch on the machine classes, the machine deployments, machine sets, and the machine objects themselves. So in the interest of time, right now, I have already created the machine classes. I have 2 versions of the machine class. It's the same thing. One is with a smaller type of machine, one is with the largest type of machines. Yes, and you can see the logs of the machine controller and the autoscaler. Autoscaler says there are no nodes in the cluster, as it rightly says, because it expects nodes to scale up and down. So what I'll do is I'll go ahead and create the machine deployment that I showed you just now. Yes. So on creating this machine deployment, you can see the machine controller picks it up. It actually creates a machine set backing it and a machine object backing it. Right now we have created a machine deployment with a single machine object, because of which you can see there's only one machine object created. Maybe I'll enlarge the screen and show you how each of these objects quickly look like when in the time when this machine is actually joining the cluster. So what I can do is cluster API. Let me show you how the deployment object looks like. So as you can see, same deployment object, the spec remains the same as earlier. Now the status part has, we have borrowed most of the status from the deployment, the pod deployment itself. Similarly, it has its conditions there, and it has the different types of replicas, unavailable replicas, updated replicas, and things like that. And similarly, you can also have a quick look on what the machine set looks like. Same as the machine deployment, minus the deployments part, like the rolling update and things like that. That's what it looks like. What's interesting is, what is expected is we have also the owner references where you can see it's pointing to the machine deployment that I just created, which is the test MD. And Yeah, it also has its own status similar to the replica set, borrowed from the replica set. And we
So
also find
one difference here is that in the failed machines, we explicitly list out the machines which are failing at that moment. So that's a slight divergence from the normal replica set status, and which eventually will be helpful for the very higher level controllers to understand which exact machines are failing and why are they failing.
yes. And finally, we have the machine object. What the machine object looks like is as expected, similar to a pod object. You have the owner references, you have the spec, and what in the status, as you can see, we have added the conditions borrowed from the node object. These conditions are updated as and when the node object is updated. And finally, there's also a status which right now is in a pending phase because the container is yet to join. The node is yet to join. And there's also a last operation which describes the last operation that was performed and what is the status. It says it's processing and things like that. So if it could be a delete operation, it could be an update operation and things like that. We also have
add a couple of more points on the node conditions, right? The node conditions here will be used for most of the health reasons. So machine set controller would basically check here, not machine set, but actually machine controller itself will understand that if Kubernetes is not ready for a certain period of the time, then it will declare the state of that machine to be failed, or the phase of that machine, right? And the next two fields is something, it's about the life cycle of the machine, about the phases of the machine and the states of the machine, right? So that you can see our framework is in a way that we have two levels of bifurcation. First level is that what's the last operation? Last operation could be create, delete, update, and so on. And for create, delete, update, whether it is pending or successful or done already. And then we have a parallel bifurcation, which is for the phase of the machine. So phases is about pending, running, and stuff like that. It could be draining in future. And so if you want to evolve it, we can keep evolving the new phases there and make the higher level controllers understand it. And the last field is about the provider ID, which we were discussing probably in the last call as well. So if you see here, provider ID is quite a good amount of information, which tells us everything specific, everything which identifies a machine very clearly on the cloud provider. So in AWS case, it's instance ID, which is unique across your subscription.
Yes. And so I'll just get back and minimize the screen, and we can see that the node you can see the MCM logs, the node has joined. You can see there's a new node running here. And you can see the autoscaler is now up and active and no longer gives the errors, warning message saying the no nodes exist in the cluster. Now what I'll do is, so you saw a simple node joining the cluster. Now what I'll do is I'll try to autoscale the cluster. In order to do that, what I have is I have already a deployment deployed in the cluster. I'm calling it an Nginx one node requests RIC. And what it is essentially an Nginx pod, a dummy Nginx pod, which requests for a memory limit of 9 gigs. And each node in this cluster currently has a 16 gigs. The machine deployment has a 16 gigs. So what it would do is each pod would actually require one. It's just to demonstrate how scaling would work. So, right. So what I'm going to do is I already have this deployment. Maybe I can quickly show you running. Yes, you can see in the screen below that it's a deployment with no replicas running. I'll just scale this deployment. I'll try to scale it up to 3, and hopefully the autoscaler picks it up and tries to. So as you can see, when the pods come up, the first one directly goes into a creating state as there's already a node running. And now the rest two are pending. You can see that the autoscaler quickly estimated that there was 2 nodes needed to accommodate this. It immediately changes the number of replicas on the machine deployment. It changes the machine deployment to 3. And you can see there are 2 new nodes, 2 new machine objects created for the same. And takes a couple of minutes. Takes a couple of minutes, and then again, the nodes would come and join, and hopefully these workloads will then be scheduled on those nodes. We might have to wait a couple of minutes. If you have any questions, you could questions, comments.
So one of the things which I would already mention is about you already saw the logs which was saying the no nodes in the cluster, right? So that is something that we have to sort out with the autoscaler folks, that how can they not rely on the node object to understand the allocatables and all those fields, and how can they actually rely on the machine class and fields like that, right? Which we are going to offer as part of the machine API stack. If that would be the case, we will not see those kind of logs, and we would not require, it's not only about the logs, but it's about that when you have a no node, and let's say you have multiple node groups, then autoscaler will actually want to decide which node group to scale up for the given workload, right? So in those cases, then autoscaler does not do anything. Right now, it does not do anything unless you have a different setup done via ASG or any other facilities from the cloud provider, right? So if that's sorted out, then we will have much better integration with the autoscaler.
So just to repeat what you're saying, Hardik, it sounds like if you'd started off with 0 nodes and tried to scale this deployment from 0 to 3, the autoscaler wouldn't have been able to create the 3 nodes, even though the machine class was available from which it could have created nodes. If you had the machine deployment that was there, and autoscaler was set from 0 to 5 instead of 1 to 5, presumably that would have still worked because it could look at the machine deployment. Is that correct?
Yes. So there would be no space yet for autoscaler to read the stuff. So mainly the problem comes when you have multiple node groups, and then the logic of simulation kicks in from autoscaler, which tries to pick up one node group out of many. And that's why it then cannot take the right decision.
Okay, so yes, and now you can see that nodes have joined the cluster successfully, and this cluster is scaled up to 3, and you can see all the pods have been scheduled successfully. This is the last part. What I would like to do is I'll just show you how a rolling update of the machines would work. So as you can see, I already have this machine class version 1 and version 2. What I'll quickly do is,
before we move to rolling update, right, I would like to mention one point which we discussed some time back about the deletion strategy for the machine set, right? So that's still an open question for us, that how do we write, what's the right way for us to decide that which machine to explicitly delete and as well as in parallel do the scale down. So we are using the priority approach yet. So if you go to the machine, any of the machine object, then you would see that inside the machine object, we have a label which says that the priority of this machine is 3. And if whenever autoscaler would have decided to scale the machines down, it will basically decrement the priority of that machine to lower number, and then it would have worked. But there is a clash there. So there is a nice point recently made up where what if there are multiple consumers of this facility and there would be a race condition. But then I would expect that if user is running multiple consumers, then anyway user will have to decide that which one to prioritize against the other, because whichever way we would try to offer, at some point this question will come if 2 external consumers want to delete the same machine or different machine at the same time, right? So that's where then they will have to decide that autoscaler should decrement it further than the other consumer, or the other consumer should decrement further.
And just to say one more thing on that point, we did have a chat with some folks from the Autoscaler SIG last week about this strategy, and they had a couple of concerns about how it behaves in edge cases. And there's not a clear alternative yet. So I think this priority-based strategy works reasonably well. It certainly works great in the quote normal cases. But we are thinking about ways to make it work more reliably across all cases.
So you want explicit deletion of explicit machines, right?
Yeah, the autoscaler wants to say, basically, in sort of one atomic action, scale down by removing this machine. And there's no API construct to do that today.
Yeah, I mean, I've been looking at the scale sub-resource. I mean, because from API perspective, this should be the exactly the same place where it should be actually put like desired. I mean, but it's only for deletion, so for scale down scenario. So, and the problem is that this thing has to propagate to the actual end resources. And also when you have like deployment and then replica set, or like a machine and then machine set, you have to also call your sub resources with the exact same thing. So it's kind of complicated from an API perspective to just to have those things.
Yes, I agree. I think, yeah, there's not an obvious answer of exactly how to do this, which is why we aren't sure what the best solution is. But the autoscaler folks have told us from day one that this is sort of a requirement from the autoscaling perspective. So it is something we're going to have to figure out how to solve.
Yes. So in parallel, I'm trying to ideating the approach where we could take up what's already existing in terms of priority classes for the pods, and if something like that could fit in. So there could be different priority classes for different consumers, and machines could be explicitly allocated to those priority class. And the way otherwise the pods work, it would just work the same way, but user will still have an option to decide that which priority class gets a better priority. So that is something that we can do, but I need to give more thoughts, and it looks like it's more of a long-term matured solution. Of course, it's still open what's the right way of doing it.
Okay. So in the interest of time, maybe I'll just quickly trigger a update as well, and then maybe we can discuss more things. While triggering an update, one thing I would like to mention is I'll just bring down the autoscaler. This is because if I keep the autoscaler up, it will try to mess with my update going on, right? And so I'm just going to bring down the autoscaler. To help with such a behavior, what we do in the gardener is responsible for basically bringing down the cluster autoscaler whenever a rolling update goes through. But maybe we still have to think it through how it would be done when we try to eventually have the machine controller for the cluster API, right? I mean, how this autoscaling and the updates would go through in parallel. Yeah, anyways, just a side note. And so yeah, what I have is for the update, it's the same spec that machine deployment spec that I had earlier, but right now it's already scaled to 3 replicas. So I've scaled the number of replicas to 3. And what I'm changing is the machine class version. So the earlier machine class version was 1. I've just updated it to 2. I'll just try to deploy this spec. So what I'm going to do is I'm just going to hit on apply. So as you can see immediately, you can see the MCM is up to something, and you can see now that there are there's another new machine set created, and you can already see one node is being deleted right now, because that's based on our update strategy that we have specified in the machine deployment, in the sense that we have specified a rolling update and we have given a max and available as 1, because of which it tries to bring down 1, and we have a max surge of 1 as well. So you would observe that there are 2, maybe I should stretch this a little. Yes, there are 2 new machine deployments, machines being created. There are 3 new machines being created, and 2, sorry, 2. And you can see this one being scheduled, and this rolling update goes 1 by 1 based on the strategy as well. And maybe in a few minutes, the cluster should go through an entire rolling update. And just to show you, maybe I should have done this earlier, on the console, on the AWS console, you can see earlier I had X large machines which are shutting down, and there are 2 X large machines which are just coming up. You can see them initializing. And hopefully, eventually, it will be all 2 X large machines, and the X large machines would be replaced. So one subtle point that I would also like to mention is, although in this case, we really don't have a realistic workload with PDBs specified here, but in a real scenario, what the MCM also does is it respects PDBs, in the sense if you have configured your pods with certain PDBs, it tries to hold on from deleting the node if possible, while tries to maintain these PDBs while doing this rolling update. It's not a sure shot, but it gives you a buffer of 5 minutes to try to adjust to this, and if it doesn't, then it forcefully deletes. So yes.
just to add, so the catch there is about the multiple drains. So if you're aware of the behavior from the Kubernetes, if you try to drain multiple machines in parallel, then Kubernetes itself basically tries to make sure that the pods running on top are respecting the certain PDBs. So we are reusing that feature rather than implementing the complicated layer where we decide which machine is the right machine to delete first and which should be deleted later, right? So basically we have imported the drain logic from the Kubernetes, and we anyway drain before deletion. Yeah.
Yes. Any questions, feedback, comments?
Is the behavior you showed with the max surge min unavailable the same as the deployment logic? I was a little surprised. I guess in my head I'd imagined that the min unavailable was taken from the number after you add the max surge and not from the initial number. That makes sense, right? So you had 3, you can surge it plus 1 up to 4, and min available is 1. And I guess in my head I was thinking that meant you would always have at least 3 nodes available, because we'd have a minimum of 1 unavailable out of the surge number, not out of the original set number. If it's consistent with deployments, that's fine. I just have to adjust my internal calculations.
Yes, it's consistent with the strategy from the deployments. So anytime tries to ensure that numbers are correct. So it should not be beyond max unavailable. More than 1 max should not be unavailable. That's all.
So the max unavailable is with respect to the desired replicas and not with taking into the max surge in consideration.
Okay.
So yeah.
So if you wanted to do concurrent upgrades of multiple nodes, I believe that the way to specify that is to set max unavailable, because then you can do multiple at a time. Is that correct? Or yes. I guess if you just set surge to be a bigger number, that would do them in parallel also, because even if your max unavailable was 0, if you did surge plus 3, it would create 3 new ones, and then wait until you had more than 3 ready before deleting any old ones. So I guess you could use both to configure parallel upgrades, right?
Yes, that's right. So by playing with those parameters, you can decide if more than certain number of machines are required to be drained, right? Even by using the same, you can also ensure that at any time. So one of the thing here is also that it's a best effort strategy. So there can always be a situation where there is no machine you can delete at all, right? Because there are the pods on top are situated in a way that if you try to delete any of the machine, at least one of the pods PDB will be violated. So then it's a best effort. It waits for 5 minutes for the drain. If it doesn't work, then it basically deletes one machine which is desired. So that's basically about it. And from the autoscaler point of view, so the next good thing is actually the integration between the machine API and autoscaler. So we should actually already start looking in that direction and start the collaboration where we could have certain asks. We already have certain asks, so we already see that one of the things that we saw that autoscaler could already do for us, and which would have made our lives much easier, right? So.
Okay, yes, you can see that the update has gone through. You can see the new nodes have joined. Maybe I can show you on the console as well. Hopefully all machines are now of the larger type. Yes, you can see there are 2x large and the x large have been terminated. So yes, that's about for the demo. Thanks. Any feedback, questions, always welcome. You can post it as comments as well. Thank you.
I guess one meta question, you're showing the demo on AWS, and I know there's the AWS implementers meeting that's happening on Mondays. Are you guys involved in that and helping work with the folks that are also trying to get stuff running on AWS?
So not yet. So actually, it's demo is for AWS, but it actually works across 5 providers already. So it's OpenStack, AWS, Azure, GCP, and Alibaba. So right now I'm more into the configuring, setting up the APIs for the machine. But yeah, I definitely want to check what's happening in different providers and with each different providers. And I guess for vSphere also some provider meetings are going on.
Did you guys port this over from Gardener?
Sorry?
Did you guys port this over from Gardener?
Port this over from, so this is a part of the Gardener.
Okay.
So this is part of a Gardener project itself. So
I thought you were reporting this over the cluster API.
Yes. So initially we had our own APIs implemented. Now we in a separate branch, I have taken the APIs from the cluster API and made our controllers work with those new upstream cluster APIs, machine API aspect. And probably for Gardener also in near future will be adopting the cluster API aspect as such when it will be mature. And just to add, so there are with this kind of things, there are a couple of interesting things we can also implement. So for example, we have implemented the safety controller, which I never got a chance to discuss about, but it's about a safety net across your controllers. For example, if there are, for any reason, by any chance, if there are any orphan machines, then that controller can basically look over the cloud provider, see if this machine is not intended to be on the cloud provider. It's called orphan handler in here, so it deletes those orphan machines. And then if for any reason by developing, if you explode the number of machines, then the intended number of machines, then it freezes the machine controller manager and so on. So maybe in future we would, once we have the right set of controllers as a base controllers, we might want to in parallel think about those kind of controllers as well. We have already taken quite a good amount of time. Maybe if there are any questions or anything, you can shoot already.
So is the goal for this machine controller manager that you guys have written to be, let's say moved over into the cluster API itself, or like where does this, like for example, right now I understand this code lives in the Gardener project, but what's the eventual goal? I mean, is it that eventually cluster API as a core will have an additional piece which will be, forked over from what you have right now in Gardener into the cluster API itself, and then it will natively function in that, or like what's the goal?
Yes, so I'll start with some background. So before cluster API started, actually, we started a couple of months back. So we had the entire parallel implementation already done earlier. But to just answer your question, our plan right now is that the APIs that we have defined there are more stuff there, right? So we just somehow want to ensure that the cluster API as a project goes in the right direction, so that the APIs there are, because we have the controllers are better tested and we have seen it really working in our landscapes, right? So we'll try to make sure that the controllers that we have written can be contributed properly to the upstream project. And anyway, the way I'm seeing is that in the ecosystem, anyway, there will be reference implementations around. So the cluster API will be the core of all of the implementation, of course, but anyway, there would be other implementations from different Kubicon or maybe COPS and all. They will anyway have their own controllers written, right? So they will just read the existing cluster APIs API and have their controllers implemented. So you can then think of Gardener and MCM in that way, but there will be just a specific separate implementation.
Right. So for example, one thing that, so like in the cluster autoscaler today, it's kind of based on different provider, right? I mean, so you implemented a provider as implement one of the provider in the cluster autoscaler. Is that right?
Yes.
So is that good? So right now, if I look at the cluster autoscaler Git repository, it supports XYZ different providers, and the goal is will just get add on to that list, and this will be another reference or implementation which now based on cluster API. But is that the direction I think we're going?
Yes. So explicitly for the autoscaler, we would actually like to get rid of our own fork. So once autoscaler would have a right implementation which talks to the machine API, then we would not have our own fork. But from the cluster autoscaler's perspective, that how they would probably maintain the providers is the answer is yes. They will have to add one more provider as the machine API and support them. And I'm not sure whether cluster autoscaler community themselves have a goals of getting rid of the providers and making them out of tree as such. Then it's anyway in the pipeline. But
yeah, I can speak to that a little bit. The folks at Google, they work on the autoscaler, were really excited about the machines part of the cluster API because they don't want to have to maintain lots of different provider implementations. Right now, all of those provider implementations are in tree in the autoscaler code, and it's sort of burdensome for them to maintain those. And like the Gardener folks had to fork the code into a different repository to add their provider implementation. I think partially because it wouldn't have been accepted upstream in the main cluster autoscaler repository. So they'd been thinking about how they could do a cloud provider abstraction and break things apart in the same way that we're doing in the main Kubernetes repo. And I think they're excited if they could say, we don't need to support providers, we can just support the cluster API and the machine deployment, and that's where you do your your provider specific code, because then they only need to have one implementation of the autoscaler. So I think realistically we'll be added as a provider in the short term, and they will keep maintaining the other providers for a while. But at some point, I think they're going to want to drop explicit support for particular cloud platforms, because they're effectively maintaining duplicate code at that point with what we've got in the machine controller implementations.
Yeah, thanks. That sounds like a reasonable plan, actually.
Other questions from folks? Chuck, I saw you kind of like flash your mute button off like a few minutes ago. Did you have any questions?
No, I did not.
Okay. All right. Sorry to call you out.
No, it's all good. It's all good.
Trying to make sure everybody feels the ability to speak up. Okay. If there are any other questions, I'd like to thank Hardik and Prashant. That was a great demo. I think it's really good to see. This is not exactly what we have in upstream repo and cluster API right now, but it's sort of where we can get to, I think, without too much trouble and too many more changes. And it looks really promising, to me at least, that we'll be able to have these interfaces that, like you said, in your guys' system, work across many providers in sort of a consistent manner, which is really what we're trying to build here. Cool. So we'll move on. The next thing on the agenda, which is, I guess, the only other thing on the agenda. So again, if people have things to add, please do so now, is Marco.
Yes, hello everyone. I just have a quick update about the cluster API provided DigitalOcean. Several weeks ago in the meeting, we talked about some stuff, but today I'm here to share that we have finished the cluster API provider. It is ready to be used. Most of stuff is done. Some things like specifying the certificate authority for cluster and integration tests will be here in several days. After that, we plan to do first release, and that's it. For now, it seems to work very well. I have been testing it for past several days. Also, conformance tests are passing, and overall, it seems to work very well. So that's mostly from my side. If anybody have any questions, any feature ideas, or want to take a look to share some feedback, that would be very appreciated. So let me know if you have any questions on Slack, on GitHub, or anywhere.
This is outstanding. Thank you for sharing, Marco.
Marco, I haven't had a chance to look. Did you guys do the same sort of copy of clusterctl, and you're using that to create clusters that we did in the other repos?
Yes, we have clusterctl for creating.
Okay, cool.
There are instructions both in the clusterctl README and in the main README about how to get started with the cluster API provider.
Awesome. Yeah, I'm really excited that you guys are working on integration tests, because that's something that someone at Google was working on for the GCP side, and then we didn't quite get it finished before he started working on something different. So right now, I think across the project, we don't really have like an EDE test to verify that things are still working, on every commit. So I'd love to see that get built. Looking forward to that.
Are we planning on moving this to the Kubernetes SIGs organization at some point?
Yes, we have talked about that several weeks ago, but the biggest problem is ownership. I have talked to folks internal in Lutz, but we are still not sure who can be owner, who have the needed requirements about ownership, membership, and other stuff. And for now, I don't have any idea, but I hope we are going to find some owners in the upcoming period. But yes, we would love to see it move it to upstream.
If you would like a non-Kubernetes owner, I'm happy to volunteer.
Okay, thanks.
Marco, you should also send...
About that, I have not asked about that on that meeting several weeks ago, but how many owners we need if we want to move the provider to upstream? Is there some rule about that, or on what it depends?
general rule of thumb is it can't just be a subset of an organization, and to try and spread the ownership across the leads of different SIGs where possible. I don't know if there's a cloud provider SIG for DO, but if there is, the leads for that, as well as the leads for SIG cluster lifecycle, whoever wants ownership, is the typical modus operandi.
Okay, there is no SIG for DO, but we are working on getting someone from DigitalOcean to join the project. So I think Andrew is interested, but we will see if somebody else wants to join as well from DigitalOcean.
There is a SIG cloud provider, which actually meets this afternoon or in 2 and a bit hours. And the reason there is no SIG DigitalOcean is because DigitalOcean is sort of part of that SIG cloud provider. And Andrew, I think, is the primary person from DigitalOcean in that group. But if you show it up or put a note there, I can, well, either if you want to show up, then that's great. I realize it's pretty late for you, but if not, I can say you're looking for owners in that meeting.
Okay. I'm not sure will it be able to show up there because it will be a little bit late over here, but I will see. I have talked about that with Andrew, but still going to see about all that stuff.
I'm happy to let them know that you are interested in more owners if that's helpful to you.
Yeah, that would be very helpful.
All right, I'll bring it up.
Okay, thanks.
Okay, it sounds like there's a possibility we may start to have sort of a critical mass of ownership here. So if you, Marco, and maybe can follow up with Chris and Justin out of band, if we can get critical mass, it would be great to move the code over.
Okay, thanks a lot.
In the meantime, I dropped a link in chat. We have a list to different implementations of the cluster API in the main cluster API repo. And you should send a PR to add yours there.
Okay, will do.
Thanks. Cool. I just dropped something in the agenda to give a quick update on CRDs. Last week was horrific with all of the meetings and so forth here at Google. So I have not made a whole lot of progress. I think Justin's made a little bit of progress on the GCP side, maybe shaking his head kind of, getting the GCP code rebased on top of Phil's branch. So we don't, unfortunately, have anything fantastic to share this week, but we'll keep pushing on that and hopefully have something soon. So again, if other people also want to sort of tinker with their things in parallel, you can let us know. I can tell you sort of how we got started and how far along we are. So
I do think it would be good to have a feature branch. I think you and I have been talking about this, Robbie, and I think it would help me at least to be able to, not have my stuff in a random fork of a fork that's moving type thing.
You mean to check Phil's PR and do a feature branch?
Yes. Also because, the changes were non-trivial, so I imagine that everyone else will also need some time to cleanly switch and not just bang, we've broken everyone.
That is different. Well, we don't just break everyone. We break you the next time you vendor, right? So that's your...
Yes, but that's...
You can't catch up to other changes until you take that large one first, right? But I guess that's a good question. Would people prefer to have a feature branch versus just changing master and saying time to rebase? As Justin and I've sort of figured out exploring the GCP one, rebasing here is going to be pretty, it's non-trivial, right? It's a significant amount of work to rebase on top of the switch to CRDs.
I think because we vendor, master is fine. People can choose when they want to vendor. I think as long as it's before the actual alpha cut, it should be fine as long as it's communicated openly.
We've been trying to communicate here that it's coming. Everybody agrees this is the right thing to do. We'd like to do it sooner rather than later, and it's going to be a pain in the butt when we do it. So
I guess the question is there anything else that we need to get into master before we break, as it were? So is it okay to break master and cluster API for a while, effectively?
I would say yes, because you're pre-alpha. You're not in the critical path because people have already vendored, but that's me. So that's my opinion.
Yeah, and I guess my hope was we wouldn't just break master. We'd at least have one reference implementation, and we've been working on GCP, but it could be DigitalOcean or somebody else who goes first and says, we've got it working. We can verify that master does still work, once you rebase, right? And I think that's enough confidence for us to go forward and break everybody else until they catch up.
That's fair.
And that's why I didn't want to just merge Phil's PR until somebody had verified that it actually worked end to end in a real environment.
Yeah, I mean, I needed some fixes to Phil's PR as well. So I don't know if I should send those upstream to Phil's PR and we use that as the feature branch.
I think that's what he and Sunil were effectively doing. Yeah.
Okay.
And then I guess also in terms of updates, Phil's going to be in Seattle next week, and we're going to sit down and try to hack this out and finish it. So even if we don't make a lot more progress this week, you should see a lot more progress next week on getting to an end. Okay, we've got 10 minutes left. Good, cool. Siddharth added something. Do you want to explain your agenda item?
Sure, I just want to kind of ask a question in general here. So I know today, for example, the clusterctl as a CLI kind of serves as the main way of how someone would go and then deploy the cluster. My question is, so today, for example, if you look at the CLI, there's sort of partial business logic kind of buried inside that clusterctl as well. Like, for example, updating the endpoints and, fetching, waiting for, let's say, the Kubernetes, the target Kubernetes cluster to be ready and some of things like that. So is there a plan to like push some of these business logic wherever deemed reasonable into the controllers to an end goal where the clusterctl as a CLI just merely becomes just a client-side tool that if you want to exercise in an easy way to get things done, you could use it. But on the other hand, if you have a cluster where you have deployed the controllers for the cluster API, then you're not necessarily needed to use clusterctl command, but you can simply do kubectl and be able to operate everything with that without any help from the clusterctl. I mean, is that something that what is the take? I don't know. I want to know more on this. I'm not sure what that.
I'm pausing because I have opinions, but I want to make sure other people have a chance to speak if they have them too. Okay, I'll jump in then. I would love to see an end state that is what you described, where clusterctl is basically just a couple of wrappers around kubectl commands. Right now, there are two things that clusterctl does that should definitely be moved out, which is preventing us from having a single clusterctl that works across multiple environments without compiling a bunch of code in. I think once we do that, clusterctl will start to resemble a little bit more of just a wrapper around kubectl. It also does the business logic of creating the bootstrap cluster right now, which is Minikube. And I think that you could definitely sort of break it apart and tell people how to do all the steps. Say, create a bootstrap cluster or use an existing cluster, run these kubectl commands and apply these manifests, do these next steps. And clusterctl is sort of just a wrapper around that that's verifying that each of those steps happen successfully in the meantime. And I'm hoping it doesn't become any more than that. We've talked, at least in hallway conversations, about whether it would make sense to build like a kubectl plugin to do this instead of building a separate tool or something else. I think right now it makes sense to have it be a separate tool, but we should try to have sort of the minimum amount of business logic as possible in clusterctl. Like, it should be a very thin wrapper around kubectl for the most part. That's sort of my take on where I think it should go.
So I suppose if we essentially try and move towards, taking out any business logic that exists. So for the logic to, let's say, create the bootstrap cluster using the Minikube, I think that, to me, my personal opinion would be, even if it were to stay in the clusterctl as an easy way of, getting started, that might be okay. But anything apart from that, potentially piece by piece, if we can just try and move it inside the controllers in a much better way, that would probably be, beneficial, I guess. I think that's the agreement, right?
Yeah, I agree. In particular, like the endpoints thing, like there's a bug for that says this should be done by the controllers. Like, it should not be done via clusterctl, right? That there are a number of reasons why that's true, but yes, one of them is getting the business logic out.
So I have a question along the line of the cluster control. Are we intending to keep that in the vendor-specific repo? Or is there any desire to move it back to the main repo?
Yeah, so the desire is to move it back to the main repo. There are 2 open issues that are blocking us from doing that. And so if we can fix those 2 issues, then we can get rid of the forks of it and just use the one from the main repo. There may be other issues that we'll figure out once we fix those 2, but there are 2 sort of known definite issues that required us to compile code in before. And we didn't want to vendor every implementation back into the main repo to make that work. Siddharth, did that help sort of answer your question? Is there more you want to discuss here, or is that?
No, I think that's, yeah, I mean, I just want to get a sense, and that helps. The clarity helps. Thanks a lot.
All right, Ashish, you got, I think what'll probably be the last thing on the agenda as we're getting low on time.
Yes, so this might be like a shameless plug. I would just wanted to kind of get some feedback on the change that I submitted, or that my change that got merged. Has anybody used it, and do you have any feedback? I saw Marco had linked this to another issue. I have been away, so I haven't kind of really caught up. So anything that I should kind of follow up on and tidy up if there is anything that is that requires tidying up? I am specifically talking about the change which allows us to have cluster API objects in their own namespaces instead of all going into the default namespace. I know David Dewart, his team was looking into using this change. I'm not sure if he's on this call.
I don't see him in the participants list at the moment. Oh wait, no, there he is. I do see him. He's muted.
So let me just pull up the pull request as well for folks to look at.
It's not specifically pertinent to your PR, but I do know that from the demo earlier that the gardener also puts machines in different namespaces. So clearly that's a direction that matches with their architecture as well. So it doesn't help verify whether your specific code worked or was effective, but I think directionally it's in alignment.
Okay. I kind of tried to finish it off in a hurry, and I wanted to make sure I wasn't being sloppy in any way. Okay, looks like I will follow up with Marco on his comment, and also follow up with Dewart offline.
Yeah, I think that would be great. I haven't had a chance to test it because I've been trying to do the CRD thing in the meantime, which is drifting a little bit behind master, so we don't have your PR on that branch yet.
Okay, cool. And anybody using it, feel free to reach me on Slack. That's all.
Great. With that, we are just about out of time. Thank you, everyone, for coming this week. Reminder that we have the provider implementers meetings. There's one on Tuesday that's sort of less European friendly, I would say, and one that had been on Monday morning. I don't know if Ilya has tried to move that to bi-weekly in the space that was left by me. The SIG cluster lifecycle meetings bi-weekly.
Hi, it's Nadir. Ilya's on leave this week, I believe. I think we were suggesting more European-friendly time would be the bi-weekly slot that's been freed up by Cluster Lifecycle. I didn't get any strong reactions against that, so I might just PR that change.
That'd be great, and I'll update the calendar once you do, if you could CC me on the PR.
Sure.
Okay, and if you're working on AWS, please also try to drop into the meeting on Mondays as well to make sure that you're at least aware of what other people are doing in that environment. So I guess we had a sort of an off-cycle, like random one-off meeting with the Autoscaler folks last week. They have a SIG meeting on Mondays if people are interested in learning more about the cluster Autoscaler, which we saw demoed earlier. And then also, if you're interested in being involved in any more sort of off-cycle meetings with the Autoscaler folks, there was an issue, I think it was maybe a KEP PR or something, where I tried to find people that I thought would be interested in those meetings. So if you're interested, you can either ping me on Slack or find that issue. And with that, I hope everyone has a great week. We'll see you soon. Thanks.
Thank you.